All right, Gabriel, take it away.
Cool, thanks, Ed. Alrighty. So, we have this PR out that's basically trying to deploy an ML model in the compile process in a way that makes sense from an engineering perspective. Um, and I think there is some open questions about this that I wanted to get feedback on. So this isn't like oh, this is what we know we should do, but more of a, you know, take the temperature of the room and like see what people think. So feel free to break in anytime. Um, so some motivation. The PR the model does pretty well that we developed. We're basically trying to replace auto tuning for gems. So this is like you have a gem shape and a hardware configuration, and you want to predict like the runtime of the gem without actually having to run auto tune. And the reason to do this is mostly compile time. So max autotune, for example, is not really enabled in training that much internally because of the compile time. And so if we could achieve max autotune performance at like a much lower compile time, I think the like the overall performance of Torch would go up quite a bit. And so I also think there's a lot of other problems that could be solved with ML that just aren't being solved with an ML because it's annoying and like untrodden territory. Yeah,
A quick question. So when you say 15% of the compile time, do you mean if I had max auto tuned it, then it would have taken like 6 times as long, something like that?
yeah, that's yeah. So like
I'm
and
surprised it's not more actually.
um, yeah. So there's some weirdness where like uh, different configs can have like anomalously long compile times because of like shared memory. So on average, like the model selected configs are like very can sometimes be like poor compile time. But yeah, on average, it like the median is like a lot lower for the compile time, or sorry for the model.
Okay.
Um, Yeah. If you saw Paul's work on like filtering out the gem configs, then that's related to this. NYC?
I'm curious, how much does these results generalize across, I guess, a wide range of hardware configurations, all of these kind of things?
Yeah. So we're gathering data on that right now. The like these numbers are from like at least two separate like H100 configs. So there is some like diversity in our evaluations, but yeah, we're trying to get benchmark results and other proof points. I agree. MPK.
Maybe this can be done through extension points. So like what if we introduce indeed like auto tune hints or whatever extension points, and anyone in inductor can register those. And so like if we believe that this helps for certain cases that you verified, you just ship this extension point first internally, and then we figure out how to safely ship it into open source. Because I think the way it is right now, it's very dangerous and can indeed introduce a lot of like unexpected results. And if it is an extension point, it's very flexible. It allows AMD or other vendors to provide their own ML networks the way they want. They tune for their models, and but we pave the path for them to do it easily.
I agree. We have a entry. So choices.py is like the main extension point for inductor. So we have some additions to choices.py in the PR, which is like the extension point that we were planning. But I agree that like getting the
So
model vendors.
consider like add an extension point, right? And then like your particular example, and we can ship it first internally, that like register extension point. But this registration can happen like automatically and outside of like PyTorch core. Because shipping something like that in PyTorch Labs, it sounds like a fantastic idea. And if people want to try, they could like pip install like as an extra dependency in Torch, we can say pip install Torch square brackets, I don't know, ML optimizations.
Yeah. That sounds good to me as well.
Because I'm also worried about backward compatibility because AOTI, I mean, it sounds great. Don't get me wrong, but like I don't know if we want to like be in a situation when somebody like 2 releases down the line saying, you know, like it leaks a memory somewhere or something, and we can't change the APIs because we released like this binary prematurely into the world, and now we have to maintain it forever.
Yeah, I mean, I agree. I agree with that. I have some alternate packaging approaches that maybe avoid that issue. Par?
Yeah, so I think it's a follow-up question from Alwan, which is, what do you expect happens if the underlying library, say Triton or Cutlass, gets updated? Do you think you're gonna have to go and update again, retrain the same models?
Yeah,
or maybe
definitely. There will be some transfer learning, but it's like the classic distribution shift for an ML model. Elias?
Yeah, just to Nikita's point of like packaging and like being an optional dependency, you know, if I think like we should weigh it on its own merits, where like what is the increase in the package size, how much of performance does it improve, like how much does it decrease compilation time? Because like optional dependencies are just by and large not going to get installed if there's like, I don't know, if there's a particular blocking point to having it be on by default, like it'd be great to hammer that out as to what exactly it is, because yeah, like optional dependencies are just rarely installed.
Yeah.
So
it's also the AOTI thing. Like this would happen prior to AOTI. So like the AOTI packaging concerns are not really relevant here.
So just to frame the conversation a bit, I think that punting it to PyTorch Labs is a good way to like de-risk short-term shipping, but I would like to spend time in this meeting talking about what the durable long-term is. So let's actually like collect some of the desiderata for long-term. Yes, Elizabeth.
Hi. So I've been working on the modeling effort here. I don't work on PyTorch, but I'd be sort of curious, like if it does seem that, you know, it is like not feasible to put a 400,000 parameter model in the compiler in core PyTorch, what could be feasible? So like a very minimal example is like right now we have these 19-ish or so max autotune configs that are already coded in there. It seems like updating those numbers should be doable. Just changing the numbers, and then there's kind of like a spectrum of complexity in terms of what you could implement. So I'm curious about people's thoughts on that.
Driss, I guess.
Mine's separate.
Mine's
actually, I'm just curious, is the model a PyTorch model?
Yes.
Okay, cool. As long as that's P0 in my mind. So
okay.
We actually, you know, we thought Jax would be better. So.
I mean, Driss, it's a legitimate question because, like, you could imagine saying, "Oh, why aren't we just doing like an if tree?" Right? Like, question.
Yeah.
MPK.
Yeah, I think like in addition to security concerns, I also want to make like an open source plea. Right now, this model is a binary drop. There is no explanation how it was trained. What is the model architecture? Just you say, here is the binary and trust us, it works. So if I'm an ML researcher and I want to reproduce the same thing, I have no idea how to do with that. If I'm a security researcher and I'm looking at the 2 megabyte binary blob with weights, okay, they are fine. They're probably 1.5 and 200 megabyte of x86 code, I will be very concerned about how this x86 code was. So like, if we want to ship something like that, we need to find a mechanism when we ship kind of a model definition and weights, and this binary gets generated preferably at the first installation on the target system, right? We should ship as fewer like randomly generated binaries as possible. So if we can move to this model, I would be much more happier from a security point of view and like binary incompatibilities, because whenever you try to build something with a specific compiler outside of our CI/CD, we will step on the problem of like when we need to update the compiler, something bad will happen. And one other example, like this will not work on the gray systems because it hard codes x86 binary, even though it says I'm for H100s. So if you have a Grace Hopper system somewhere in the wild, your model will not work. And I'm not sure if we have any mechanism to carefully test for that.
Wait, just a moment. So there are a lot of hands, but I think Gabe does have slides. So does anyone have questions relevant to this slide? I otherwise want Gabe to get through his slides. Okay. Gabe, can you just go through your slides?
Yeah, sure. So, I think these are the three main questions that I would I think are critical to discuss. So what format do they take? How do we distribute them? And then how do we update them when the distribution shifts? And these are some considerations. I wanted to call out the security that's been talking about, forwards and backwards compatibility, and portability. So there's a bunch of ways we can reduce the compilation time and inference time. You know, we can do it like on install or ahead of time. We can do it async. We can also take advantage of hardware-specific auto-tuning on the model itself, and not with the model, but like on the model itself. And this point I mentioned about training users being unwilling to trade compile time for runtime. So these are, you know, hierarchy of two options for the artifact storage. So storing them in tree makes it easy to deploy, but the models are small, but if use cases proliferate, then it doesn't scale very well. Then out of tree, so we have to keep the repos in sync, and then like maybe we could do like FTP or like async downloading if the use cases proliferate. And so these are like kind of some broad options for model loading. So we could export it, like just export the FX graph plus the weights of the model and then compile it at runtime or at install time. We can utilize AOT inductor. I know there's been some pushback on that already, but AOT inductor performs quite well, so it's worth thinking about. And then we could do something more manual, which is like, you know, looking at the output of inductor code gen and then storing it with the weights and doing something more custom. So this is like a basic model that I put together for benchmarking purposes. And then these are some like benchmarks for loading the model. So you can see AOT inductor performs quite well as like a manual solution. The FX compile is a bit, FX loading it is okay, FX compiling it maybe not so much. And then this is kind of what the AOT inductor looks like, these three slides. I won't go over everything here, but you can see there's like some binary stuff that has been pushed back on, so confirmed. So ideally with security, we want to avoid binaries. Safe tensor is a third-party dependency, which could limit adoption. I personally think that weights only equals true with torch load is like okay for the weights. I would, if someone has other thoughts, that would be great to hear.
It's fine. Like your security model, it's fine.
Cool. Sounds good. And then with model updates, we're going to put the PR is not complete. We want the training code in tree. And then we can update the model with torch gen and hopefully have some like button type infrastructure internally to like okay, push button, get PR of updated model, so that it's not dependent on someone's specific knowledge updating it. And then also, I think it's critical to have some internal model monitoring for distribution shifts when we update libraries. So that's all the slides I have. So opening up the floor.
Yes, go Francisco.
Yeah. So you for now it's only format rules, right? And I wonder, like, couldn't you just provide in a separate repo two functions? One where you actually execute your model and get the configs for that input set of inputs, and then one that consumes basically the those inputs and dispatch to the kernel that you want, and then that can be a separate library that could grow in size and users could depend on and potentially even inductor. But why do we need to plug it inside inductor?
Yeah, I mostly think it's like an adoption thing, like Elias says, but.
Okay, go Alvin. You're muted, Alvin.
Sorry. I'm a little bit confused about the different slides. In particular, the security says no binary, but half of the other slide says we're actually going to ship binary to speed up load time and execution of all of that.
I mean, it's a trade-off, right? Like,
So Alvin, to be clear, we don't have a concrete proposal under consideration. So, like, I think part of what I want this meeting to be is collecting requirements. So Nikita has quite reasonably said we shouldn't have binaries checked in to the Git repository, which I also agree with. I don't think, for example, there's a security concern for loading a model from us, because if we wanted to like run arbitrary code, we could just run arbitrary code. Like, there's nothing stopping Python from running arbitrary code. So that doesn't make sense as a security model consideration. But binary supply chain, yeah, sure. But we do distribute binaries to people. So like in the end, like, you can imagine having the weights in the wheel. Like, I don't think that is intrinsically a security problem. Maybe the weights though, like, that's something, you know, that is difficult to audit. But binary blobs are difficult to audit anyway. Go, Mark.
Yeah, so my suspicion is like what people want isn't like a model for them to auto-tune. Like, what people want is like just the shapes and the hyperparameters that will help them run fast. So you could presumably like offline run like all sorts of things, have like the biggest like ever parquet file for all the matmul auto-tuning heuristics. And then people can just like at runtime like load that, like just have facilities for inductor to pre-populate like some cache. And I think this sort of solves a lot of the problems. Like, basically the code then is like out of tree. It's not ran by customers directly unless they want to. And I think it solves like sort of a lot of like maybe Nikita's preemptive concerns.
So hang on, Mark. Are you proposing that for every single size you like dump it, or you're proposing a decision tree?
So I'm proposing that you pick popular shapes. Like, basically you can, like, for instance, go over all of Torchbench and just like pick the shapes that are there and then make sure that you run well on those shapes.
I don't think this solves the functional requirements they have, right? The whole point is that this works on all sorts of sizes that like show up, and there are a lot, right?
Well, it works by interpolation, right?
Well, I mean, so if you want to say we should do a decision tree, that's an interesting question, and I wonder if Elizabeth has anything to say here. But if you're just literally going to like hard code like 1,000 sizes, I don't think that actually flies. Like, I don't think that actually solves the functional requirement.
Why not? I guess maybe that's a leading question. Like, my point is that like it's 1,000 sizes and like
So, Mark,
like,
this is what
still not very
NVIDIA
big.
used to do with Kublas a couple of years ago, right? Like, they put more and more logic about the weights and so decision tree, I agree with that, is a better suggestion, because there always will be a shape which is not something that you hard-coded, but it is there.
So Elizabeth is obviously the expert here, but from what I understood, the base, like a small neural net model, like outperformed a decision tree by quite a bit, even a gradient boosted tree.
Go ahead, Elizabeth.
So right now what we have in there is a regression model where you put in a bunch of configurations and it predicts runtime, and then you say like which one had the fastest runtime or which were the fastest 20 and benchmark those. So you could do something like that with a decision tree, but a different way to do it would be to have it not output runtimes, but you put in your matrix shapes, hardware, et cetera, and it would just recommend a configuration directly. No prediction of runtime, just say what config. I played with that a little bit, but it seems to work when you have really small configurations, like with Triton. But then if you're looking at something with Cutlass, where you could have enormous numbers of parameters, and then you have to start worrying about like which parameters are like valid in context with which other ones, that it's hard to have like a decision tree for each one. It might be doable. It's not something I pushed super hard on, so I'm like 50-50 on whether this could work, like whether you can distill the regression model into a smaller regression tree, or sorry, decision tree.
Go, Elias.
Just for the discussion of other hardware that's not supported, like I definitely think as part of this work we should have an interface that people can plug in their own model. But even aside from that, like you can achieve the same thing locally, which with just like longer auto tune times, and there's nothing preventing someone from doing that. Or like we publish this interface, and some hardware developer, like some hardware company, like makes their own model and like publishes it, like they can hook in. But I don't think we should like prevent like improvements to like the hardware we're targeting here because of like concerns for like longer tail hardware, which like the reality is that like to some extent we're going to always tune for some hardware more than others just based on capacity or what we look at. And yeah.
MPK.
So this is why, like, I think there was a slide about benefits of out of tree and drawbacks. I think one of the benefits of out of tree is that we can update the weights more frequently than we release PyTorch, right? Because I'm not sure how confident we are that the decision tree that we build, or like the regression model, kind of covers what we want to see. I suspect as we release, we'll probably find something out and want to update the weights. And it's so much easier to update the weights in out of tree repos than an in-tree repo. So it could be a PyTorch dependency. We say that torch depends on the model something or other. As long as we define like a stable API for those extension points, we can update the weights and extend to more architectures, as Elias suggested, but like keep the interface between inductor and this extension library. And yeah, if you want to make it mandatory dependency, it could be, but like again, I think the weights, at least initially, better be served out of tree, because we'll be able to iterate on them faster.
Paris.
Yeah, so this reminds me of, as I mentioned in QDNN, where they had a model that they trained internally to predict which configs of their multiple convolutions they would dispatch the model to. But I think in the end, this didn't actually pan out that well, because maybe maintaining that list didn't work, and nowadays we just go for auto tuning. I wonder, like, is that like gonna potentially lead to the same outcome in here? I mean, I'm not sure why we predict the runtimes and then take the argmax versus just predicting the configs, for example, which would make this like a discrete classification problem. But that's like a separate story. So yeah, I'm partially convinced actually.
Go NYC.
I wanted to get back to your question, I guess, earlier, Ed, on like you wanted to focus here on like if we were to ship a model, how would we ship it? And I guess my read from the room is either we are in a narrow enough case where we have simpler solutions that don't require a model, or we are in a situation where the model sounds interesting, but we're not at the level of stability or maturity that we say, oh yeah, let's ship in core. We're at the level of like, let's add an extension point for you to easily be able to plug that in and get exactly the result you have from the current PR, but just from out of core, so that we can continue experimenting with this. We can have more, gather more data on what our real usage internally, real usage externally, and I guess revisit with hard data to convince people on which side we want to go.
So this is an okay outcome, but then I want to push the room to then define what is it like. What would it take to actually make you confident, right? So yes, when I hear Francisco say, "Oh, Kudina tried it, and in the end it was too difficult," like I'm very curious, like what actually happened, right? And then how do we convince ourselves that that's not going to happen? Because if you just say, "Well, like hopefully we'll get more data," but what? Like this just leaves Gabriel in a lurch. Like I don't know what he's going to do with that.
Well, I'm not sure it really does that. In particular, depending on I don't know, Gabriel, how much of your goal is internal, external, average runtime, specific runtimes. If a lot of the goals are for relatively specific models or for specific use case internally, you can completely achieve that from out of tree. And we don't need to answer that question for Gabriel to achieve that goal.
Yeah, I mean, like internally, like people have I think that the like lookup table works very well internally. Like, you know, we have a lot of resources to throw at running exhaustive auto tuning, right? So, I think I view this more as like a lower resourced benefit, and then also people who are particularly compile time sensitive, like all training workloads, basically. So I think like the types of like customers this hits are actually like very good for Torch Compile, like in terms of like increasing adoption for maybe stuff we haven't been as like present in.
Go, Driss.
I just wanted to say that before you two left, we're doing a decision tree, and we like essentially ship a decision tree for scaled MM. We were doing one for async TP. You can get pretty good results and like a decent amount of speedups over the naive thing. That being said, like Lazos added full cutless auto tuning support, which essentially like sweeps over more params. I think the geo mean speedup was 8%. So I don't know. Good for that. But I'm just saying, like, I still think that if you wanted to have something smarter than just like crude grid search, decision trees for MMs and cutless at least tend to work pretty well for a large swath of problems.
Go, Elias.
I guess I don't really understand all of the trepidation around like the weights getting outdated, or like I don't know, maybe they're like less they they're not as good as we want them to be. Like the status quo today is that we have like 20 hard coded configs that don't work particularly well, and now we have this ML model that's like been trained on thousands and thousands of shapes. It's probably been trained on like more data than we have of any heuristic in PyTorch, and like I don't know, we don't like I like it's one thing to define like a stable API, which I definitely think we should do, but in terms of like we're worried that the model is not as good as it could be. Like I think we should look at it based on the merits of like the incremental improvement to what exists in the code base, which is large, and like go from there. Like
one thing that makes this a little difficult is we don't actually have that data in the slides. Gabriel, I don't know if you have that data handy or not.
What, like the generalization?
Yeah. Like how much benefit are we getting from it?
So in our local benchmarking, it's pretty significant. There's a workplace post that I can I don't have the specific numbers off, and I don't want to quote the wrong things, but I can link the workplace post for the exact numbers. It's like the big ones are replicating max auto tune with much lower compile time, and then exhaustive with also much lower compile time. Because at the end of the day, like you can't exhaustive auto tuning is the ceiling for this performance, right? So we're just trying to reach that.
And also just to note that like these configs, they only They will only affect results if we're better than Ku+. So the baseline is always Ku+. That's always the default. Like the risk here, in my opinion, is like pretty low.
Go APK.
So I have two maybe points. One is about CUDNN going back and forth. Like what we observed with the new version of CUDNN, it increased memory footprint. If you have a lot of different shapes and you want to auto-tune for all of them and JIT compile, it creates a problem. So like having a precompiled kernel is sometimes good. But I want to talk a little bit maybe of what irks me about the current approach, and I wonder why we're doing it this way. So I know that we fine-tune it for H100, but why do we run the prediction model on H100 itself? Why it's not a CPU model? Because that would have solved the problem of like not having to worry about CUDA updates, right? Because like CPU APIs are pretty stable, and we can ship the same model and it will work on like, I don't know, CUDA 12 dot something to CUDA 13, as long as people have the same H100. So maybe like a little bit on the model inference, it should be CPU inference unless there is a really, really strong reason. The model seems pretty small to run on CPU. Thank you.
Yeah, like, so one thing to note is that the model is hardware specific. So you're only running H100 models on H100, right? So there is some like guarantee about like where is this being run. And then the second,
Q-beans are very CUDA driver specific. So I don't want us to be in a situation when users have H100 with a driver full, and for some reason they will not be able to run Q-beans that you will ship with like, again, unless we change the distribution model a lot. I encourage you. So like, I agree we should probably limit to the hardware, but also should we limit to the hardware family? Like, I don't know if there's...
Nikita, hang on. I'm confused. Like, we ship, like, you know, Cubans in PyTorch. Like, what's the problem?
We load them very differently, right? We let the CUDA runtime take care of all the compatibility issues. With AOTI, when we ship them as separate files, we need to unpack them somewhere in the file system and load them. That creates a lot of problems. So I would prefer to eliminate this issue. And also, again, like there is H100 and there is like whatever variants, right? There are HLL40 or something, which is a tiny H100, but exactly the same. And I wonder if we can like easily extend the heuristics. And one more thing is Grace Hopper, right? So right now we exclude hoppers. I'm not sure why we should. Like, I know we want to be conservatives, but maybe not.
I mean, one question as well is, even if you have different weights, the architecture is the same, right? And you can compile the architecture, which is the 5-layer MLP, into even like a binary, a CPU binary, and just run that. And you can load different weights depending on the architecture. And the weights can also be on CPU. So I don't think you need to have Cubans for this model, right?
No,
that's my point, yes.
Yeah, you definitely don't need Cubans. So like the main default usage for inductor in this case is Triton, right? Like we're generating Triton matmul configs. So we could just generate like Triton binaries, or sorry, not Triton binaries, like Triton output code, you know, like a Python file basically. And then the like extension for where this is being run is like 1-to-1 on like where the
Oh, Gabe, I wanna push on this a little. So you really want it to run on GPU. Do you have like inference time numbers that are pushing you this way? I'm just trying to understand.
Yeah, it's on the PR. The inference time numbers are on the PR.
Do you mind just popping that open real quick?
Yeah. I don't have the CPU comparison on hand. But
well, take your word for it. So like what's the difference?
The difference so eager GPU, for example, maybe is like is a upper bound, lower bound on it. Eager GPU runs in 4 seconds, and AOTI compiled GPU runs in like 30 milliseconds.
How often are we calling it typically?
It takes 4 seconds to call forward on this model.
What? Yeah, that's weird.
That's insane.
It could be CPU. You know, benchmark.
No.
But even
that
CPU is like
big.
5 layers.
Yeah.
No. Sorry. This is not the model I showed. This is like the one we're running.
Well, tell us about the model we're running. So what is our model architecture?
400K neural net. 400K params neural net.
Like just a bunch of stacked linears, or
Yeah.
Yeah. 4 seconds still sounds high to me. It's a pretty like straightforward multi-layer perceptron. Nothing weird going on.
We can
Just
run
like-
Llama
yeah.
3 on a mobile phone at like 12 tokens a second. I'm surprised it
Yeah,
takes.
yeah. Okay. It could be bad benchmarking. So I'll focus on that.
Maybe my last, sorry for jumping the queue, my last point why I don't want to run it on GPUs. We know a lot of situations when GPUs are very like fine-tuned to maximally occupy the memory, and pushing even a small model into GPU can result into something that used to fit into memory no longer fitting into memory. We've seen something like that with like Llama 3 VLLM inference just a few weeks ago when like allocating an extra 32 megs pushed the entire system into ohms. So if we can run the inference on CPU, we kind of isolate ourselves because we don't need the model, but correct me if I'm wrong, we never unload it after we fine tune it. So that would be my argument why I prefer to run it on the CPUs if possible. But New York?
Yeah, I had a slightly different point.
yes, let's open a different direction.
I wanted to poke a little bit more at Elias's comment earlier on like the baseline we have today is kind of terrible. So why are we pushing back on improving it? And I would like to understand Elias on like I think where do you stand in the one of the point here was like, oh, let's just put an extension point for anyone to be able to provide these things. And how do you feel about this proposal? Is you concerned that this would not be there by default, the program we're providing here, and so most people will not see it, and so it will not achieve the global benefit? Or do you think we have a very specific advantage here that we are the ones providing that model? Is a critical advantage. We have something that no one else has, and we need to be the one providing that model, and no one else can.
So sorry, Alvin. Why isn't it not just when you install Torch and run Torch compile, I want good perf without waiting a long time to compile? Like this is what Elias said.
But
Like I'm a user, I install Torch, I use Torch compile, I want it to compile fast, and I want it to be good. Why not? Like this seems perfectly reasonable to want.
It is, but why are we the one providing that model? Why are we the
No,
only
because
one
they installed Torch. Like obviously, if people want to do strange things to like make things better, they can. But like
I think my problem with this one is that we very narrowly focus the architectures we care about. Like if I see that it supports, I don't know, 4090s and B200s and A100s, I say yes, that sounds great. Right now, it narrowly targets H100, and it feels a little bit weird to say, if I run PyTorch, I want to run it fast only if I run H100.
Okay, but this one's like not hard for Gabriel to
clear,
fix, right? They just
yeah,
collect the data on those hardwares and then have models for them.
But like, how are we going to make a decision tree about what hardwares to support with these accelerated models and which won't? Like, if somebody from community says, I really care about this one, will we consider that?
So for the 4090, like you would still get good perf. You're paying more compile time because we haven't trained a model ahead of time to like, accurately estimate which configs are going to be most profitable, and so there's a compile time hit, which like it's going to be impossible to just have a perfect like estimation of all hardwares, train a model on every hardware. Like it's not feasible. And I would like us to like consider the incremental improvements of this change as opposed to like, I don't know, like an ideal thing that doesn't exist that no one is.
Okay, now Elias, I have a question for you, which is plausibly, which hardware would we actually ship models for?
We know.
I mean, go ahead, Driss.
Like we know which model. Like I think like we could also look at usage statistics of where PyTorch is run in the community. Like it's run on H100s. It will be run on B200s. And there's a long tail of other hardware.
Okay, so like something like 3 devices, or so we're imagining 3 model variants.
Yeah, and we'll have an API that like users who want to contribute and like contribute a model for this longer tail hardware can plug into.
We'll accept it in the
Oh.
core eventually. Like, I think that's my problem. Like, if I'm on H1, like, I don't know, I have some weird setup. I run this model and I say, well, here's the weight, please accept it. Like, what would be the acceptance criteria? And when the size limitation kind of starts to bite us.
Your suggestion where we structure it where it's a third-party package that PyTorch now depends on, we can like dog food the interface, and then you can say this is how you can make your own package for your own hardware that you can pip install, and if it's available and the system matches, we'll use it. Like, is it still possible to do this and also dog food some hardware?
And let me put it differently. It sounds like people are saying, no, we would not accept those pull requests. Like, put it in your own, package.
Yeah. I
But
think so.
then
But
why
also,
do
do we
have
have?
hardware?
Do we even have evidence? Like we're talking about like almost exclusively Triton matmulls. Like, what hardware do we even know? Like Triton matmulls outperform whatever the optimized vendor like baseline is. Like, can we answer that for all of these like long tail hardwares? I feel like this is like a little speculative.
Go Paris.
Yeah. So, I mean, in general, when someone implements kernels for an operator, they're the ones best placed to optimize that. Why then NVIDIA inside Coblas don't choose or dispatch to the best possible model, given that they are the owners of everything in there, right? Ultimately, they were, except if they don't have interest in making the fastest matmulls out there. But I would see, like, given that how library updates like impact the weights that we care about, I would see that as like a separate library that provides matmulls. And whenever we update the underlying library, Triton, I mean, if you change the Triton pin, we're gonna have to change the weights most likely. And that is like its own library of optimized gems through machine learning, kernel selection, whatever, or hyperparameter selection. But I see that as its own building block, basically.
NYC.
Yeah, no, just to answer to Elias, I feel like there is a weird disconnect in my head right now in the discussion of like, we are claiming this neural network is good for generalization overall, and at the same time, whenever we say, oh, but we can't do the generality because we don't really care about it, and we need to push more for like open-ended, you go back to say, no, actually we only care about one hardware.
No, but they're just saying it generalizes for the hardware. Like, there's nothing contradictory about that.
But they're restricted to
I think-
800s.
But
I think it would be good to open source the like training code of the model, but like it's yeah.
I think if you're saying we want the baseline for Torch Compile to be better and faster overall for OSS users in particular, we're saying internal is solved already with what we have. We're talking OSS users at large, then I would argue that we most likely want to focus on the open-ended community solution rather than something that is going to work for H100 for the foreseeable future.
So a lot of the way that Torch Compile is built is like built off of H100 and H100 dashboards that we run on CI and we benchmark changes against. Like, this is already the status quo that we try to make we try to auto-tune things in the model to work generally, but also like we work off these particular models. And one other thing to Francisco, the difference between this being a Triton matmul library is that like there's a particular value proposition within Inductor, which is that we can like epilogue fuse or do other more complicated fusions, as opposed to like a standalone gem. Like where the goal is to like have a gem config that gets us close enough to Kublas such that we can profitably like fuse onto those gems. So like the value as a standalone library is a little different.
I'm curious, Elias, on what exact like what is your stance on like we are very overly tuned on H100 today already, and I don't see that necessarily as a good thing, right? Or are you saying this is actually a good thing because we can actually do a good job at it?
I guess what I'm saying is like, uh, the I agree that it would be great if we had access to every hardware like under the sun to like like train all of our heuristics on. Like we don't today. In this particular instance, we are like serving a model that would only apply to this particular like hardware, and we can open source the training of it and making it like make it available for other folks. But like I don't know.
I think I definitely understand that for us to handle even more hardware is a challenge. I I do think that one benefit we have here, and one of the big point of PyTorch open source, all of that is we have the option of like putting ourselves not in the critical path here, and push more proactively to say, hey, we need NVIDIA to handle this kind of H100 auto tuning at the inductor level, and of course, we are very vested in the H100 part of it, but we can also get other people in the community to handle other hardware where we say we don't have the resources to deal with this other hardware. But we do provide the right extension points for anyone who cares, and trust me, AMD will care, Intel will care. All of these people, they will very happily
I was
do
about
it for you.
to say that, like, if we landed in core 2 weeks later, Intel will come with a patch saying, here's the optimum weights for XPUs. And they give me the same 1.7 megabyte binary and say, please review. And I have no idea how to do that. Like, who should be on the review? Like, will we accept this patch? Like, we'll land this change in core, Intel comes, say, this is the great optimized model for XPUs. What are we going to do?
So,
like, who is going to review those changes?
So we have like the model code, and then the weights are like a separate, blob or whatever. Like so hopefully it'll just be like updated weights, right?
So we will accept weights from Intel, we will accept weights from XLA, we will accept weights from IBM Power 9, we will accept weights from RISC. Like, everyone will want to land some sort of a random weights because we open this code path in core. Are we saying that we will accept all the weights like at the face value?
If the model wasn't in core, you'd still have the same problem, right? Like, is it impossible to community ship models based off of binary blob code review?
Yeah, I just want to say that all of these problems seem solvable. Like, as I said, like, we don't have a proposal that solves all of them, but like, if people are willing to put in the legwork, these problems seem solvable. Go, Elizabeth.
I think if we want like more than one team to be able to contribute this, we need to formalize to like make the benchmarks very reproducible and transparent. I think that would help attract more attention from researchers, and otherwise it'd be kind of impossible to compare.
Okay, so we're getting close to the end of time. I'm trying to... All right, so Gabriel, first I'm going to like ask the most out of you, and then I want you to push back. So basically, here's what I want that requires minimal work from us. And then I want you to say, no, like, I think some of these actually are reasonable. Essentially, what I want you to do is I want you to come with a proposal whereby the models don't have to live in core. You have to somehow solve for the distribution you want to solve for. Probably you don't want to download them on the fly either. Like, that causes security problems as well. So you need to somehow design an architecture whereby the weights live out of core, but you still don't have the distribution problem, and it is extensible so that other people can do things, and also have a clear guidance about, like, here's how the weights are produced. Like, this is all of the documentation we're going to do here for the reproducible pipeline. Basically, like, so basically you are setting the precedent for the first model in PyTorch. And it's not even going to only be for inductor auto-tuning configs. People are going to want to do other things. So basically you have to do a good job at doing this. So like, this would be like, it sounds like the ask from the room. I want you to push back now. Or you can say, yeah, I'll sign up for all of it, and then we all.
The thing I don't like the most is the living in core thing. Like, I think that will like basically not realize the benefits.
Well,
So
so I'm asking you to come up with a design where I don't have to check in the weights into the PyTorch Git repository, but you still get distributed by default on a binary wheel. And if you're like, I have no idea how to do that, then okay, so then I can come up with a technical proposal that's bad because I just came up with it. But like maybe something like, okay, so the straw proposal from the room was that we have a external library, PyTorch depends on it directly, and that library somehow causes the thing to become like basically having it installed causes Inductor to be able to find it. I don't know if like Alvin and Nikita, you guys like this plan. Like, I'm like, but like, there you go, straw proposal.
It's a solution. It will work, and if like things go really bad, we can just replace this dependency with a dummy repo that doesn't register anything, and we're good, right? If things works well, like it creates its own community, we can distribute weights for like IBMs and Intels and AMDs and whoever companies that should not be named, and be happy with that.
Right. So you can't even say it's technically impossible because we have a straw proposal.
We have a solution, and this is how like custom Inductor backends already registers themselves. So like we can have one more extension point in the same venue saying that, I'm registering Inductor choices. That sounds very feasible and very ecosystem friendly, in my opinion. I don't know, maybe I'll have a different one.
No, that's also how a lot of the other free backends work today. Like all the other free backends work like that today. You can do fancy auto load and things like that, so the user doesn't even need to change their code. They don't even need to trigger the import of your package. Inductor doesn't necessarily even have to know about this either. So yeah, there are many solutions that exist if you go that path for sure.
Yeah, I'm happy to at least address all of these. Like, I'll come up with like a really good reason why each of these isn't a thing we should do, because I like most of them.
So for the like scariness of blobs, does it being a non-optional runtime dependency versus being in core actually make a meaningful difference? I guess
somewhat. Like there is a binary size limit, right? So again,
that's
like,
the main one I was thinking about.
Another one, again, like I don't want to deal with the problems that we distribute weights that benefits like high sense 5 accelerator or something, right? If someone else does it in a different repo, I'm happy with that. I don't want to be in the reviewing end of this binary blob into PyTorch. Because again, if we're saying that we want to generalize, there will be hardware vendors that we don't want to be in core.
So maybe one way I would put that down, Chris, is at the Python dependency level, we already have existing mechanism to pull in different dependency depending on your hardware, your version, swap them in and out, have other vendors provide this dependency for us, have them own these dependencies. Like we have all of that already existing that we can leverage and that map pretty well, which if we put things in core, we bundle the whole thing kind of, and we don't really have a choice. Or we need to build that kind of thing now. Now we need to have custom build that will pull in these binary blobs if you do X, but not if you do Y, on a whole bunch of things. And whatever we freeze into PyTorch is forever frozen once we generate these wheels.
That makes sense. Sorry, one other quick. What's an example of one of those packages? Like the first thing to mind is like we depend on SymPy, we depend on PyTorch Triton. Is it at that level we would add a inductor kernel thing?
Yeah, I mean, yeah, that would make sense. And yeah,
okay.
And you can even say like, in the base image we ship on Colab, we should have the inductor T4 package by default.
Yeah, I still don't know. Like, I mean, in a past life, I did train. Like, I would use DVC or something and try to come up with some reproducible pipeline to generate the model. But like, otherwise, I don't know how I would accept PR. Like, I don't know how I would review those PRs, even if it's at a different library, because that's very attractive.
Problem, right? It's in different repos, so it's the owners of this problem. They should figure out with the standards of review and model weight, right? Like PyTorch community does not have to figure out what would be the proper review process of dealing with that. And when we establish this process, we can migrate it into core, right? I'm not saying that like in a year from now, we will not have some sort of a test that validates that your model weights like lead to some net positive. But I think right now, I really struggle to understand like what is a meaningful review of such thing.
All I'm saying is it sounds, even if it's external, a very attractive attack surface.
Correct, but that again like makes it smaller and exposes it to fewer people. Like
Yeah, so like concretely, I would like you should try, and maybe you'll come back and say it's not possible. But this should be a pure Python package with no C build step, and the only binary is the model weights that you're loading with torch.load weights only. And then maybe you'll come and tell me why like actually it runs so much faster when you compile it, but like this should be the default choice, because if it works, then you have sidestepped a lot of gnashing of teeth.
Yeah, I think this is like totally technically possible. It just takes effort.
Okay, so that's why I'm like, okay, we're asking you to do a lot of things, and we don't have to lift a finger. So like, is this okay?
Yeah, I think it's fine. I think like I do like hear all of the criticisms, and like I do think it's like a big step for PyTorch for this model. So I want to do it right, mostly so that like more interesting things that are not like gem tuning, like scheduling problems, or like, you know, like stuff that ML would actually like be insanely powerful for, get cleared better. So yeah.
Okay, any last comments? Otherwise, we're gonna stop. All right, thank you everyone for lively discussion. Sorry anyone who wanted to talk about anything else. All right, we'll see you in 2 weeks, because next week's we're on break.